All right, so we're about to start our lesson on arithmetic sequences. You can go ahead and start with the warm-up where it says to find an explicit formula for each sequence. So what you're trying to do here is you're trying to write a rule or an equation in the form a sub n equals that will give you that pattern. So go ahead and pause the video, try these four, do the best that you can, and then come back and you can see how you did. All right, so here are your rules or your formulas. Now, if you didn't get these, do not panic, okay? Because I've only taught you how to do it by trying, right? I've mentioned a few ways to get them, but today what we're going to do is we're going to learn how to do these, and then in our next section, we will learn how to do these, okay? All right, so let's go ahead and get started. The reason that we are going to learn how to do the two on the right is because they are arithmetic sequences. The denominator on this one is an arithmetic sequence, but we'll learn how to do that. And I'm gonna give you a formula to help you get there, okay? So what is an arithmetic sequence? An arithmetic sequence is a sequence that has a constant difference, which we use the letter D to represent that, between consecutive terms. So what you're doing is you're looking for each term, and then you're looking to see how do I get the next term, and if there is the same constant, that is, difference, which is plus 6, or minus 2, minus 2, minus 2, the same difference each time, then that is arithmetic, okay? All right, so let's look to see if these are arithmetic. It says if it is arithmetic, then find the value of D, which is the difference, so the constant difference. So we are going to say, what do I need to add or subtract from 5 to get 11, which is 6. So if the plus 6 continues, then this is arithmetic. If it doesn't, then this is not arithmetic. So this is plus 6 here, plus 6, and plus 6. So yes, this is arithmetic, and then our constant difference D is positive 6, which is just 6. Voila. Okay? All right, looking at the next one, I will do it with you, and then you can pause the video and try the next two on your own, which I think you could do the rest of these on your own, but I want you to see what I do here. So I'm checking to see if it's arithmetic. So what do I add or subtract from 3 to get it to be a 9? That is plus 6. And then if you look at the next one, that is plus 18. So this is not arithmetic. No. You might be saying, but it's times 3. Why didn't you say it's times 3? Because I'm not checking for anything else. I'm checking to see if it's arithmetic, right? And because it's times 3, it's also not arithmetic. It'd have to be plus 3. Okay. Go ahead and pause the video, try the next two. All right, this one is a no. Okay, this is a no, and if you're like, I got yes, you did not continue to check. So this right here is plus 4. This right here is plus 4. And if you stop there and you're like, yep, it's plus 4, this is plus 2. All right? So no, that's not arithmetic. Looking at this next one, you should have yes. And D is a negative 8. Okay, let's go ahead and move on to how we will be writing an explicit rule or formula. Okay, it's called a rule, it's called a formula. I call it both, right? I'll say write a rule, write a formula for an arithmetic sequence. So it says the nth term, right? The nth term, which a sub n is the nth term, right? It's the nth term of an arithmetic sequence with first term a sub 1. So this would be your first term in that pattern, in that sequence, sorry. And the common difference, but the first term a sub 1 and a common difference D is given by, and then here is our equation. So to find it, in order to write a rule or a formula, you need the first term and the difference. So you know how you need, in order to write an equation of a line, you need the slope at any point. It's very similarly to write an arithmetic rule, you need the first term and the common difference, which is the slope, all right? Okay, so let's go ahead and do this. These formulas will not be provided for you on your test, so you do have to make sure that you know them. All right, so this says write an explicit formula, which is a rule, an equation, for the nth term of this sequence, okay? So it doesn't tell us if it's arithmetic, so first we have to see if it's arithmetic. So let's look for a common difference. To get a 32 to be a 47, we would have to add 15, add 15, add 15. So this is arithmetic. To write an arithmetic rule, you need two things. You need the first term, 32, and you need the common difference, 15. So we can write our rule. Once again, looking up there if you need to, it's a sub n is equal to a sub 1, the first term, which is 32, plus, and then n minus 1 times d. Now, in MML, on your test, anywhere, it's going to say in a simplified form. This is not in a simplified form. It should look like an equation of a line if it's in a simplified form, right? So I'm going to have to distribute, combine like terms. So we have 32, distribute your 15, so that's plus 15n minus 15, and then we have a sub n is equal to 15n, 32, and negative 15 is positive 17. So there is our explicit formula or our explicit rule. Explicit formula, explicit rule, whatever you want to call it. All right, now it says find the 12th term. So if you have a rule, that's easy, right? Just plug in 12. So a sub 12 is equal to 15 times 12 plus 17. Calculators are allowed in this chapter. So if you don't have your calculator out, get it out. Pop that in your calculator or do mental math. You get 197. Okay, moving on to the next term. Next one. One term of an arithmetic sequence is a sub 8 is equal to 50. So what that's saying is that the 8th term is 50. The common difference is 2. Write an explicit rule. So once again, to write a rule, we need the first term, which we were not given, and the common difference. So I was given that. So we have d is equal to 2, but we still need the first term. So what we're going to do is we're going to solve for the first term. Some of you might be saying, well, I'm going to write down 50, and then I know the common difference is 2, so I'm going to subtract 2 until I get to the first term to figure it out. Yes, that's fine and dandy for this problem, but what if I gave you the 800th term? Do you have time to do that? No, right? So we have to make sure we have an algebraic way of doing that. So as a reminder, our explicit formula is a sub n is equal to a sub 1 plus n minus 1 times d. We were given our difference is 2, and we were given our 8th term is 50. So we can solve for a sub 1. So we're going to say we get 50. We don't know what our first term is, plus, but that's when we plug in 8, our 8th term, and our common difference was 2. All right, so we can solve that. We have 50 is equal to a sub 1 plus 8 minus 1 is 7. 7 times 2 is 14. Subtract 14 from both sides. And we have our first term is 36. Once again, if you're saying, I already got it because I just kept doing minus 2, great. But if I gave you a term that was farther away from 1, I would have beaten you, right? Okay, so now we still have to write our rule because we didn't do that yet. So now we're going to use this again, but this time we're going to use the first term in D. So we have a sub n is equal to our first term, which was 36, plus n minus 1 times our difference is 2. Once again, don't leave your rule like that. Don't leave your formula like that. Simplify it. So to distribute a 2, and then combine like terms. So we have 2n plus 34. And if you have 34 plus 2n, obviously that's the same answer, but this looks like an equation of a line to me. I just like it better, but it's not wrong to have 34 plus 2n. Okay, next it says 2 terms of an arithmetic sequence are the 5th term is 10, or a sub 5 is 10, and the 10th term is 110. Write an explicit rule for the nth term. Okay, so we're gonna have to write a formula. Then find the value of n for which a sub n is 70. That is a follow-up question, okay? So I will do that after I write a rule. So there are multiple ways of doing this, okay? I personally see an easy way to do this, and then I see, well, both are easy. I could write a system, two equations with two variables, right? I know that when I plug 5 into my formula, I get 10. And I know that when I plug in 10, I get 110. So I can write two equations with two variables, and I can write a system and solve it, right? Like I can do that. We know how to do that. That's algebra 1. But there's an even easier way. The reason that there's an easier way is because this is an arithmetic sequence. If it's an arithmetic sequence, we know that we get a linear equation. And to write an equation of a line, we need a slope and a point, right? So if you look at what you you have 2 points. We know that when we plug in 5, I don't like that. When we plug in 5 into our equation, we get 10. And we know that when we plug in 10, we get 110. So with having 2 points, we can get slope, and then we have a point, and then we can write a rule, right? So that's what I'm going to do. That's how I'm going to do it. But the only reason I can do this is because I know it's arithmetic, okay? So let's go ahead and do that. So I'm going to find the slope. I lost myself for a second. So the slope is y2 minus y1. So 110 minus 10 over x2 minus x1, 10 minus 5. So that's 100 divided by 5, which is 20. Okay, so the slope, 20, done, okay? And now I can use a point and the slope, right, to finish my problem. Now I can do y minus y1 equals m times x minus x1. I can use that. Or I can do it just like I did the last one, which is what I'm going to do. So I'm going to say, all right, now I have a point and the slope. So I'm going to use a sub n equals a sub 1 plus n minus 1 times d. But there's so many different ways to do this, and I honestly do not care which way you do it. So I'm going to do 10 is equal to a sub 1, which I don't know. So I'm going to put a sub 1 plus n minus 1 times d. So when I plug in 5, I get 10. So 5 minus 1 times my difference, which is 20. So I have 10 equals a sub 1 plus 4 times 20, which is 80. Subtract 80 from both sides. And I get my first term is negative 70. So negative 70 is a sub 1. And now I can write my rule. So I have a sub n is equal to negative 70 plus n minus 1 times my difference, which is 20. And then just get that cleaned up, right? We want it in a simplified form. So negative 70 plus 20n minus 20. So my rule is a sub n is equal to 20n minus 90. Okay? Once again, if you didn't hear me, I'm going to make this a little bit longer than I need to, is once I had this 20 right here, the way that I did it is fine, okay? But I also could have said, all right, now I have a point in the slope. I'm going to do y minus y1, which is 10, equals m, which is 20, times x minus x1, which is 5, and then distribute. Y minus 10 equals 20x minus 100. Add 10 to both sides, and notice I get y equals 20x minus 90. I get the same thing. That's less work, so I probably would even do it that way. There's so many different ways to do this. All right, we still do need to answer that follow-up question. So to answer that follow-up question, it says find the value of n. That gives you a sub n is 70. So I want to know what numbered term is do I get 70 for? So I'm going to do 70 equals 20n minus 90. Add 90 to both sides. I get 160 equals 20n. Divide by 20, and I get n equals 8. So the 8th term is 70. Okay. All right, so now let's move on to another problem. So this says find the 500th term of this sequence. Okay, so I'm going to say I need to find a sub 500. So I need a sub 500. So what that tells me is I need to plug in 500 into a formula or into a rule. And it's like, oh, I don't have a rule yet. So what we're going to do is we first are going to write a rule, all right? So first off, we have to check to see if this is arithmetic, which, spoiler alert, it is, because that's all that we know so far. So plus 5, plus 5, plus 5, plus 5. Yep, it goes through, okay? So it is arithmetic. Our difference is 5, and our first term is negative 4. So we can write a rule. We're going to do a sub n is equal to a sub 1, which is negative 4, plus n minus 1 times 5. So now we can clean this up. Negative 4 plus 5n minus 5. Our rule is a sub n equals 5n minus 9. And now we can find any term we want. We want the 500th term, so I'm just going to move this over a little bit and say my 500th term is 5 times 500 minus 9. So my 500th term is 2,500 minus 9, which is 2491. Once again, you can use a calculator for that if you want. All right, so this is the last one. Fabulous. Last one is a word problem. People see it and they're like, oh, it's not a big deal. The only thing that's a big deal about it is the sadness of Tommy's raises. So it says, Tommy earned $50,000 in his first year at his job. So year 1, $50,000. Great. That's not a bad salary to start with. He gets regular raises on a yearly basis. In his second year, he got $50,700. Tommy, quit your job. $700 raise is not great. In his third year, another $700, $51,400. How much did he earn in his 25th year? Oh, Tommy, hopefully you don't stay there 25 years, but let's find out. Okay, so we are going to need to find the 20. When we plug in 25 into our rule, what do we get? So we need to write a rule. In order to write a rule, we have to make sure it's arithmetic, which it is. It's plus 700 plus 700. Then we need our difference, which is plus 700. We need our first term, which is 50,000. So let's go ahead and write a rule. A sub n is equal to a sub 1, which is 50,000, plus n minus 1 times 700. Clean this up. We have 50,000 plus 700n minus 700. So our rule to find out what he makes in any year is 700n plus 49,300. Okay, so that's the rule to figure out what he earns any year. So if we want to know how much he earns in his 25th year there, we can plug 25 into that. So we're going to do 700 times 25 plus 49,300. Pop that into your calculator, and after working there for 25 years, his salary is going to be $66,800. Leave, Tommy. You're not appreciated. Okay. All right, so that's it for today. We will also be learning a formula on how to find how much he made there in 25 years. Okay, but that's not today's notes. Go ahead and get started on that homework.